Hi everyone, this is lesson 3.4.5, and in this lesson we're going to be looking at logarithmic word problems. Example 1.
Okay, this question says the sound intensity in decibels, okay, is defined as, let me give you the equation right here. Now, although it's important that you give an information like this is typically not the equation that I would encourage you to use. Now, I'll show you what I intend for you in just a little bit here. We're going to take the information given here, but I don't think this is the way we should continue to work with it. Okay, where I is the intensity of a sound, okay, and I naught is the reference intensity. Okay, a certain motorcycle is idling at 20 times the intensity of the average sound of an automobile. If the average sound level of an automobile is 80 decibels, what is the decibel measure of the motorcycle? Okay, let's identify the information that we're given first of all. Or let's first of all identify some variables here. So we're going to let Im be the intensity, okay, of the motorcycle. Now, what we mean by intensity is essentially the amount of energy coming off the motorcycle into the air there, okay? And we'll let I sub A be the intensity, okay, of the automobile. Now, we're not interested in talking about this in terms of like joules of energy and whatnot. When we work with intensities, we're typically going to work in this course about comparing the two as ratios. So then we will have the dBm. This will be the decibel level of the motorcycle. Okay, and then dBA will be the decibel level of the automobile. Okay, so those are the variables we're going to use here. Now, the equation that we were given here, okay, we were told that the decibel level is equal to 10 times the log of the intensity of some sound over some reference intensity. Now, to use this, or actually, to use this, what we probably want to do here, especially because in this case here we're talking about intensities, probably want to solve this equation for that intensity here. So we're going to divide by 10. So we'll take the decibel level divided by 10, and we'll also just do the logarithm of the intensity over the reference intensity. And then because this is a logarithm base 10, a common log, to get rid of the logarithm, we will make this, okay, we will take base 10 to this exponent, and that will equal this intensity over the reference intensity. Okay? So now, when we do this, and actually, you know what, we might even do a little bit better than that. I might even just bring up that reference intensity and make this I naught 10 to the decibel level over 10 is equal to the intensity that we're looking at. Now, we are being asked to compare the intensities here. Now, we are told in this problem here that the motorcycle, okay, its idling intensity is 20 times that as the car. So we are being told here, or given this ratio, Im over Ia. Now, and I'll deal with that in just a second here. What we want to do with that is put in the intensities for this to simplify this expression here. So the intensity for the motorcycle, if we're given that this is what that looks like, this is going to be the intensity, the reference intensity times 10 to the decibel level of the motorcycle divided by 10. So this is going to be the reference intensity 10 to the decibel level of the motorcycle over 10. Okay, that's the intensity of the motorcycle, and the intensity of the car will be same thing, the reference intensity 10 to the decibel level of the car over 10. So now in this ratio here, notice that the reference intensities cancel. Okay, so this ratio is going to be the ratio of these guys right here, except when you're dividing powers, we know that you're just going to subtract exponents. And now notice that our exponents here are two fractions, but they do have common denominators. So this is going to be the intensity, the decibel level of the motorcycle minus the decibel level of the automobile all over 10. And that's the equation we want to use. And you know what? that's the equation that you should be using. You should almost memorize this. Now, granted, the things that we're going to compare here will change. There won't always be motorcycles and cars here. But this pattern here, basically intensity of 1 over the intensity of 2 should be 10 to the decibel level of 1 minus the decibel level of 2 all over 10. That pattern is always going to hold. Okay. Now, let's solve this particular problem here. We are told that this ratio is 20, and we're told that the decibel level of the automobile, I believe it was the automobile, was 80. So this is going to be the decibel level of the motorcycle minus 80 over 10. Okay. Now, we are trying to solve for the decibel level of the motorcycle. So we need to get the variable here, which is this dBm, out of the exponent. So to do that, I'm going to take the log of both sides. So the log of 20 will equal the log of 10 to the decibel level of the motorcycle minus 80 over 10. Okay, but there's an added bonus to a problem like this because we are dealing with a logarithm base 10, a common log, and this is a power of 10. These are inverse operations of each other, and so what will happen here is that the left side will be the log of 20. Nothing's going to change there, but this is just going to reduce down to the exponent. So this is going to end up becoming the decibel level of the motorbike minus 80 all over 10. And now the process of solving for that is actually quite simple. I'm going to multiply through by the 10 times the log of 20, and then I'm going to add 80 to get the decibel level of the motorcycle. And when we do that, we're getting approximately 93. Decibel level of the motorcycle. Okay? So that's what this question was particularly asking for. Now, again, just as an aside here, one of the things that you might want to note here is that it might be easier just to work with an equation in this form right here. Sorry, my mistake, over 10. Okay, over 10. This might be an easier way to just approach those problems, but you'd have to memorize that equation.
Example 2.
This question here says, how many times more intense is the sound of a normal conversation, okay, at 60 decibels than that of a whisper here at 20 decibels? Okay, that's a good question. And actually, it's a nice question here. If you think back to the previous question, where we left off, okay, I left off saying that one thing you might do to that would be of benefit here is just to memorize this equation right here, that when I compare sounds, the intensity of the first sound divided by the intensity of the other sound. And by the way, this is what you're going to get asked for almost all the time, is that ratio. If you're going to get asked for anything about the intensities, it'll be this ratio here. And this will be 10 to the decibel level of the first sound minus the decibel level of the second sound all over 10. Now, if you're being asked for one of these guys up here, the decibel levels, then you just take the log of both sides and solve for the missing variable, which is quite easy because when you use a common log of a power of 10, you're just left with the exponent, which is kind of a wonderful little property there. But in this case, it's a little different here. We're going to compare normal conversation to a whisper. Okay, so that's going to be the intensity of normal conversation over the intensity of a whisper. And that'll be the decibel level of normal conversation minus the decibel level of a whisper all over 10. Okay, now this will be equal to this power here. All I got to do is plug in the numbers though. So this becomes 60 minus 20 over 10. And this actually can be done quite easily. 60 minus 20 is 40, divided by 10 is 4. And 10 to the 4 is 10,000. Okay, so the answer is, okay, that normal conversation, okay, normal conversation is 10,000 times louder than a whisper.
Example 3A.
Okay, this question says, the pH scale is used to measure acidity or alkalinity of a substance. The formula for pH, and here you go. Now I know there's going to be someone who argues about something here, but just take it for what it is. Okay. Okay, pH is equal to the negative log of the hydrogen ion concentration. Okay, so our first question here says a solution has a hydrogen ion concentration of 1.6 times 10 to the negative 4 moles per liter. Okay, so we know that this right here is going to be 1.6 times 10 to the negative 4 moles per liter. Now, again, I'm not hugely concerned about the units right now, but moles per liter. Determine the pH of this substance to the nearest tenth. Now, this is really just a matter of plugging this in. So therefore, our pH is going to equal negative log, okay, of our hydrogen ion concentration. So that is going to be the negative log of 1.63 times 10 to the negative 4. Now, there are a couple ways you can do this on your calculator. And so I just want to take this opportunity to show you both of them. So to start off with, I might do the negative log, okay, of 1.63 times 10 to the power of negative 4. Okay, and I get that at the nearest tenth, 3.8. And that's fine. There is, however, another way of doing this. You could do the negative log of 1.63. Now, and use this right here. Now, I want to make sure that you see what I'm doing here. Zoom in on this just a little bit. Okay, I am going to press the second feature here and then the comma button here to access the EE. Okay, and when I do that, it puts that little E there. Now, this is basically the scientific notation here. And now, if I put negative 4 there, the calculator understands this to be 1.63 times 10 to the negative 4. Press enter, and I'm getting the exact same thing. So the calculator sees no difference between those two. Okay, and then my answer here, as I've just seen, okay, is going to be approximately 3.8. There you go.
Example 3b.
If tomato juice has a pH of 4.2, determine the hydrogen ion concentration scientific notation to 1 decimal place. Okay. So the pH is 4.2. Well, here's our pH formula right here, negative log of the hydrogen ion concentration. So this is what we're trying to get at right here. So we just really just got to plug this in. So this becomes 4.2 is equal to the negative log of the hydrogen ion concentration. Okay, let's bring that negative over. So negative 4.2 is going to equal the log of the hydrogen ion concentration. And now we got to change this. Okay, because we're using the common log here, the base is 10. In order to get that hydrogen ion concentration out of there, I got to get rid of the log by converting this to the exponential form. So this will become 10 to the negative 4.2 is equal to the hydrogen ion concentration. Now that's great. Sorry, this is great here. 10 to the negative 4.2 is fine, but that's not the form they wanted it. What we're asking you to do here is to take this and make this 10 to the power of negative 4.2, press enter. This is what we want here, okay? The 6.31, okay, times 10 to the negative 5, okay? Or this one says to 1 decimal place here. So this would actually be 6.3 times 10 to the negative 5 moles per liter. Okay, because they want it in scientific notation, so we got to take it to this level here. Nothing wrong with this number, but this is the number that they want.
Example 3c.
So this question here asks us how many times more alkaline is milk with a pH of 6.6 than lemon juice with a pH of 2.1. Now, what we're asked to do here is to compare these two along the pH scale here. Okay, so if this is our low end and this is our high end, okay, this is going to be more acidic and this is going to be more alkaline. Okay, so we've got, what have we got here? Sorry, lemon juice is over here at 2.1, and we got milk over here at 6.6. And I know it's not close to that. I mean, this is over half because I know where the half is, around 7 there. But yeah, we just need a comparison here. Now, each step along the pH scale here, okay, I should write it like this. Each step represents a power of 10. Okay? Each step represents a power of 10. So if we want to compare the alkalinity of these two, okay, I got to take this value right here and subtract this value here. So I'm going to get here 6.6 minus 2.1, okay? And what do you get when you do that? Well, I am going to get 4.5, okay? So there are 4.5 steps to go from here to here, okay? This is a jump of 4.5 steps here. Each one of those refers to a power of 10 in terms of alkalinity. Now, if I was going the other way, if I wanted to compare acidity, I'd have to consider the steps going this way, and I'd be dropping down 4.5 steps. Okay, so you got to just make sure that you understand how we're comparing this here. So the milk is going to be more alkaline. How many times more alkaline? Well, this is going to be 10 to the 4.5, which is approximately, okay, 31,623 or 31,623 times more alkaline. Okay. Now, if I wanted to test how many times more acidic milk is, then I would incorporate the negative, because if I'm going this way, okay, this is actually a drop. If I'm talking about acidity, my acidity drops this way. So this is a drop of 4.5 steps, and so it just becomes the reciprocal of that, 1 over 31,623. But in this case, we were asking to compare the alkalinity, and so that's how we would do that.
Example 4.
Okay, now this question says, earthquake intensity is given by I is equal to I naught 10 to the m. Okay, where I naught is the reference intensity and m is the magnitude measured on the Richter scale. Now, very, very similar in structure to the decibel scale. If you think back a few minutes ago here. Whoops, sorry. An earthquake with a magnitude of 7.3 is followed by an aftershock with a magnitude of 5.1. How many times more intense was the earthquake than its aftershock? So very similar to the decibel problems here, what we're being asked to do in this particular problem is compare the intensities. I'm not asking you for any specific intensity, I just want to know the ratio of those intensities here. So first of all, let's take a look at the information that we're given. So we know that the magnitude on the Richter scale, and we'll use m sub e for that, for the earthquake was 7.3. Okay? And we know that the magnitude of the aftershock here was 5.1. Now, the formula that we're given here, okay, I equal, whoa, sorry, my pencil's falling apart here. Okay, I is equal to I naught 10 to the m here. This formula here is going to allow us to create a way of comparing these two things here. I want to compare intensities here, so I want the intensity of the earthquake, and I want to divide that by the intensity of the afterquake. Now we're going to use this equation as a model here. So in the numerator, I've got the reference intensity times 10 to the magnitude of the earthquake over the reference intensity times 10 to the magnitude of the aftershock. Okay, now the reference intensities here are going to cancel. So this ratio here is going to be equal to the quotient of those two. But when we're dividing powers with the same basis here, we just subtract exponents. So this will be 10 to the me minus ma. This is actually the equation that I really think you should memorize and work with. Just like we did with the decibel scale here, really what we should do with the Richter scale is the intensity of one earthquake over the intensity of another is 10 to the magnitude of the first one minus the magnitude of the second. I think you'd be far better off if you memorized that rule. Now don't think of this as being another rule you have to memorize. This is almost identical to the decibel scale, except with the decibel scale we divide the exponent by 10. It's the same pattern though. Now here, what we're going to do is we're going to enter in the information we know. We are looking for that ratio, and we know that the magnitude of the earthquake was 7.3 and the magnitude of the aftershock was 5.1. Okay, well, that right there, I mean, you just go right to your calculator here, and we can evaluate that, and we're going to get that this is approximately 158. Okay, so the earthquake was approximately 150 times larger than its subsequent aftershock.
Example 5.
Okay, in this question, we're told that the earthquake intensity is given by I equals I, the reference intensity, I naught, times 10 to the n. Well, we knew that from the previous question, where I naught is the intensity, is the reference intensity, it should say, and m is the magnitude as measured on the Richter scale. A particular major earthquake of magnitude 8.1 is 140 times as intense as its aftershock, so let's determine the magnitude of the aftershock. Now, like I said before, I think you should be thinking of it in terms of this equation right here, which we talked about how you would build this in the previous question, but now let's just jump right to it, okay? Now, we're going to let 1 and 2 be exactly the same as what we did in the previous question. We're going to let that be the earthquake and its aftershock. So this will be 10 to the magnitude of the earthquake and its aftershock. We are told that this ratio here is 140. Okay. We are also told that the magnitude of the earthquake was 8.1. What we don't know is the magnitude of the aftershock. Now, to answer this problem right here, I got to think, well, what am I going to do here? The variables in the exponent. Oh, variables in the exponent, we use logarithms. So we'll take the log of both sides. So the log of 140 will equal the log of 10 to the 8.1 minus the magnitude of the aftershock. But this right here is a gift because I'm using a common log, which is a base 10. This is the inverse of 10 to the 8.1 minus the magnitude of the aftershock here. These are inverse operations, so they're going to cancel each other out. So what we're going to be left with is this wonderful, just the exponent there, this wonderful little expression that's just the exponent. So log of 140 will equal 8.1 minus the magnitude of the aftershock. Now I'm going to bring the magnitude of the aftershock over, the MA over here, 8.1, and then I'm going to subtract the log of 140 just to get that term by itself here. Now I can go to the calculator and I'll get that the magnitude of the aftershock is approximately 5.953 ... just to the nearest, let's say the nearest tenth here. Actually, that works out nicely. It's just going to be 6.0. And that's what we were looking for here. It is much quicker to just use that form, this form up here, than it would be to try to build this question from scratch every single time. You're going to find that you're always coming back to that particular pattern regardless. But there you go.